Okay, today under acids and bases, we'll be going through common indicators. First off, what are indicators? Indicators are added to solutions of unknown pH values to determine their pH values. This table over here shows some common indicators which you need to know. This is very important. So let's go through some of them. Methyl orange, you need to know that there's a difference in color in the acidic solution and in the alkaline solution. In the acidic solution, the color of the indicator for methyl orange is red. However, in alkaline solution, it is yellow. You also need to know what pH range the indicator changes color. So for methyl orange, it is from 3 to 5. And you need to know for other indicators as well because the pH range varies. When methyl orange is placed in a solution of pH 2, the color of the solution becomes red. As alkali is added to the solution and pH increases to 3, the solution begins to turn orange. As the pH increases further to 5, the solution turns yellow. So let's take a look at this worked example over here. It says a reaction involves two specific endpoints at pH 4 and pH 9. From the table above, suggest two indicators that can be used to determine these endpoints. So there are actually quite a number of examples, but we only have to use two. So let's look at pH 4 and pH 9. So from looking at the table and looking at the pH range, I realized that I can either use methyl orange or screen methyl orange for pH 4 because the pH range is from 3 to 5. And for pH 9, I realized that the only indicator is phenolphthalein because the pH range is 8 to 10. So methyl orange and phenolphthalein. Let's look at universal indicator. The universal indicator contains a number of dyes that changes colors according to the pH of the solution. This table you need to know. So when the universal indicator is at red, the pH is either 1 or 2. When it's green, the pH is 7. When it is violet, it is either 12 or 13. When doing neutralization, it is important to determine when the pH of the solution is exactly 7. Indicators like bromotyl blue are preferred over universal indicator. Why? Because they have a distinct color change at specific pH values, whereas it may be harder to observe the gradual color change in the universal indicator. And that is 2 minutes of chemistry. See you next time.